Okay, so in this video I'm going to show you guys how you can use the binomial formula to find the coefficient for a specific term in a binomial expansion. So in this problem, let's find the coefficient of the term for z squared q to the 20th in the expansion of the binomial 3z minus q to the 22nd. Okay, so this is how we're going to start. 3z minus q to the 22nd means we got to do 3z minus q. Geez, I'm having a hard time today writing that. 3z minus q times 3z minus q times 3z minus q times 3z minus q. That's 1, 2, 3, 4. We only have to do that 18 more times. We got to multiply out 3z minus q. Let's maybe first multiply out 1, 2, 3, 4, 5 of these. So that means we got to FOIL this out, which would be what, 9z squared minus 3 zq's minus another 3zq plus q squared. Adding like terms, we'll get 9z squared minus, those are like terms, right? 6zq plus q squared. We got to take that, and now we got to multiply that to a 3z minus q, FOIL that out. Then we just got to do that about 18 more times, and we'll be there. I'm just joking. I just showed that to you guys to try to get you to realize you do not want to do that. You're not going to try to multiply out 22 of these things together just to try to find what the coefficient for the one term that's going to be the z squared q to the 20th term. It'd be absolutely maddening, insane. It's crazy. Don't do it. So actually everything that I just showed you, forget. That's not what you're going to want to do. There is a better way. So in general, if we have, I'm having a really tough time writing. I think I'm got to get some calories. I just ran a long run, so that's my excuse. Okay, if I have a binomial, a plus b to the n power, and I had to multiply that out, right? Like whatever that exponent is, it could be 20, it could be 22, it could be 2, whatever that degree of that binomial is. If you were to multiply out all the terms, they all have the following form. N, choose 0. Now you should, if you're on this topic, there is a whole topic just about what this involves, combinations and what the formula is and so forth. Here we're just going to use a calculator to try to figure out what these combinations are, so that's kind of nice. But anyway, it'd be n choose 0, then it would be the first term a to the full highest power of n, and then there'd be absolutely no b's. It'd be b to the 0. Plus, then it'd be n choose 1, then it would be a to 1 power less than n, it'd be n minus 1, and then it would be b to the first power. And then it would be n choose 2, a to the n minus 2 power, b squared, and it would keep on going like that forever and ever until you got to the last term, which would be n choose n. It would be a to the 0, b to the n. Now, this is what's going on in general. If we just look in at one specific term, let's say if we want the term where that second term, b, where b has exponent r. So like we want a very specific term where the b has a specific exponent. Now again, it's going to be an actual number and a problem, but if we want this specific r-like term, we're just going to use this. N choose r, a to the power n minus r, b to the r. So this is going to be the one that's going to be our moneymaker for this problem. This is going to get us the exact term we want. So let me show you how you can use this. Now, let's revisit our specific problem. In our problem, we were looking at this binomial. We were doing 3z minus q raised to the 22nd, and we wanted to find the coefficient of the z squared q to the 20th term, okay? So a couple things that you're going to want to keep in mind, all right? First off, in our formula, when we're using this formula, n really comes from the highest exponent possible in the binomial, which is indicated by the exponent of the original binomial, okay? So for this problem, my n value is really going to be 22. So n is 22 for this problem. That's my highest exponent, okay? Now, the r value that we're going to use in this formula is really the exponent that I want on that second term. So it's, see how it says b to the r power? So what that means for my problem is I better know what in the world b is first, I guess. So the b value is just the second term. So here, I'm going to let b be negative q. That's going to be my b value. Okay, so if it's a minus sign in there, include the negative with that b value. That means this, so that's my b value. This guy is my a value, the first term. So my a value is 3z. And in my problem, I want to have the q, my second term, to have an exponent of 20. So that is my r value for the problem. I'm going to have an r value of 20. Okay, so I think I've just picked apart every piece that we need to use for our formula. I know what the n is. I know what r is. That's the exponent I want on that b term in my binomial expansion. So here it's 20. I know what my a value is. It's just the first term, 3z. And I know the b value is that negative q. So I'm going to try to use this formula and show you guys how it works. So instead of, let me just maybe rewrite it. Okay, so it's n, choose r, a to the n minus r power, b to the r power, where n is 22, so it's going to be 22, choose the r value, which is 20. Then it's the a value, which is 3z, so I got to put 3z in parentheses, to the n minus r. N is 22, minus r 20, and then it's times b to the r. Well, b is negative q, and that's got to be raised to the rth power, which is 20. So I have all of the pieces in there. Now what's nice is you don't have to do this 22 choose 20 by hand. You're going to have the Alex graphing calculator, or not graphing calculator, but the scientific calculator, and it works the same like this one. What you can do is you're going to bring up the n choose r, which I believe on this calculator, I have to hit PRB and choose number 2. Now for you guys, when you bring up that scientific calculator, you'll see just NCR. And the thing is, it's almost easier on the Alex one, actually it is. You have to type in the 22 first on this calculator, and then I have to choose and choose our 20. So on Alex, it will look like this. When you bring up NCR, you'll see a box, C box, and just remember, you'd have to put 22 in there, 20 in there. So in this calculator, it looks like 22 NCR 20. A lot of calculators will write it like that. And when I hit enter, it automatically makes the calculation. So that's 231. All right. So I have 231 just for this part. Then it's going to be times 3z, and then I have to do 22 minus 20, that's 2, right? 22 take away 20 leaves that exponent to be 2, and then I have negative q to the 20th. So now you're still not done. Some students will say, oh, my coefficients is 231, but it's not 231. You're really not done yet. You have to kind of finish some of the math over here. 3z squared means you have to square the 3 and the z. And I'd also, in the negative q, that's like negative 1 that I have to raise to the 20th power and raise q to the 20th power. So that's a little tricky, and a lot of students will forget to distribute that power to each factor in the product in the base. So it's really 231 times all this stuff, which is 231, and then 3 squared is 9. Then I'd have a z squared. Now, negative 1 raised to an even power is just going to end up being positive 1, and then I have q to the 20th. So at the end of the day, I have to multiply 231 times 9 times 1 technically equals, or times z squared times q to the 20th. So really my coefficient is going to be the product of all that, which is just 231 times 9, and that's 2079. And it'd be z squared q to the 20th. Now my answer is only the coefficient, which would be that guy right there. And that would be the end of this problem. Now, just as a quick bonus, if you're looking at that and you're like, man, that was a little tricky, let's just jump right to doing another problem like that, maybe just a little bit faster, and I'll show you how to use the formula, okay? So example 2, let's say I want to find the coefficient of your y cubed z to the 10th of the expansion 3y plus z to the 13th. Okay, so maybe let's start off by identifying our ABCs, right? So, or not ABCs, our A, which is the first term. So A in this problem is 3y, B in this problem is z, N in this problem is 13. Now R is tricky. Remember, R is going to be the exponent we want in the expansion of that B term, which in this problem is the z. This is my R value. It's 10 in this problem. Okay, it's always going to be the exponent that we want on that second term, which again is 10. Now, I'm using the formula n choose r, then it's a to the n minus r, b to the r. So if I plug in all the good stuff, n is 13, so it's 13 choose 10, that's my r value. The a value is 3y to the n minus r is going to be 13 minus 10 power, and then it's b to the r, which b in this case is just z, and r is 10. So that would be my setup with the formula. I can use my calculator to do 13 choose 10, and that's 286. So this becomes 286. Then it would be 3y, 13 minus 10 is 3, and then I have a z to the 10th. So I have to do 3 to the third, y to the third there. Here it's just z to the 10th, and I have a 286 times that. So it looks like the only other numbers to multiply would be the 286 times my 3 to the third, which is 286 times, I think that's 27. So 286 times the 3 to the third, or 27, gives me 7,722. So it'd be 7,722 y cubed z to the 10th. That is my answer there. So I hope this video helps you. Good luck on your quest to conquer the binomial formula.